Hello. What we're going to do today is we're going to be using a multimeter to look at resistances. Now, over the last few lessons, you've looked at how you can use a voltmeter and an ammeter and use our key equation, resistance is equal to potential difference divided by current, to calculate resistance. This multimeter, it is called a multimeter because you can use it as a voltmeter. This bit here, if you've got the dial to that bit there, it's a voltmeter. Can use it as an ammeter, but it will also just read the resistance, and we're going to do that today. Now, in the exam, you need to know how to calculate the resistance using an ammeter and a voltmeter, but for today we're just going to be using this bit here to read the resistance off directly. So I want to show you how to use this, and then you're going to use it to do two separate experiments looking at resistors that the resistance changes, so they're non-ohmic resistors. Now, the resistors that we use, if we're looking at a fixed resistor, you've probably seen a fixed resistor like this for when we were doing our characteristics of a potential difference current graph. Resistors don't normally look like that. That's a ceramic resistor, and it's quite good because it doesn't heat up so much. Resistors normally look more like that, okay? So I want to show you how to use these to show you how to use the multimeter, and then we're going to be looking at using some different resistors when we do our experiments. So in order to use this to read resistance, we've got to turn the dial around to this area here. You see that mark there, ohm? That tells you that it's going to be measured in ohms, so it must be resistance. So turn the dial of your multimeter round till you get to the 200. Now that 200 means if we use it on this setting, the biggest resistance it will be able to read is 200 ohms. If it's bigger than 200 ohms, we might have to put it in that setting, 2000 ohms, or even one of these settings, and you can see this one's 20k ohms. That means 20 kiloohms, 20,000 ohms. I will show you that later on in the video. So, first thing you need to know is how to connect up the multimeter. There's 3 different connecting holes here. You always use the bottom hole, and for the resistances, and for whenever you're using this for GCSE, it's the middle hole. So ignore the top hole, just those 2 holes there you're going to plug your wire into. Okay, then you've got to be looking at what you're going to connect the other ends of the wires to. Well, we've got to put these onto the resistor. Now it is possible just to hold that onto the resistor there, and it should give us a reading. Okay, and you can see there we've got a reading of around 12.7. So it is possible just to hold the other ends of the wire onto the resistor. However, some of the resistors are some of the components we're going to use are quite delicate. So it's useful to use a component holder like this. So here I can just clip a resistor in, and you should be able to see if I clip those in and I can join up the other bits of the wire there and there, we've got a resistance there of 14.4 ohms. Okay, 14.4 ohms is the resistance. And if I just show you what the whole circuit looks like, I've just got the multimeter connected up to the component holder. Right, so that was our first one. If I just move that resistor out of it, let's try a different resistor and see why we need to use different settings. Now, you can see at the moment there's no resistance there, and the multimeter is reading 1. It reads 1 if the resistance of what's there is bigger than the setting. Now, there's nothing there at the moment, just air, so it's going to have a huge resistance. So that 1 says, well, whatever's in between here has got a resistance bigger than 200 ohms. Right, now, if I plug this one in, I just clip this into the component holder, you should be able to see that it did flash up with a number, but it's settled on 1. That means that this resistor must have a bigger resistance than 200 ohms. So I'll move it up to its next setting, 2000 ohms. And can you see, a wire's getting in the way a little bit, but I've got a reading now of a resistance. The resistance of this is 469 ohms. So it is more than 200 ohms, less than 2000 ohms. So I've got that on the correct setting. So remember, if you ever get a reading of 1, What that means is you need to turn up the setting to a bigger setting, and then we hopefully will get a reading. Okay, so I've got another resistor here. I'll just swap it over to the component holder. And my next resistor, if you can see, it's saying 1 on 200, so I'm going to turn it up to 2000. Still saying 1 at 2000, turn it up to 20k, and it's coming out to be just over 10. Now that seems weird, because if it was bigger than 2000, how can it be 10? Well, the answer is because we've got that k on the setting. This actually means 10.13 kilo ohms. And I'm sure you're familiar with K because of kilometres and things like that. In ohms, what that would be is 10,130 ohms. Okay, well, that ohm doesn't look very good. So, if we've got it on any of the other settings, the 20k, 200k, 2000k settings, the number it gives you, you've got to multiply by 1000 if you want to know it in ohms. Okay, I've got one last one just to show you. So I'm starting at 200 each time, and I'm moving up so I can see which one has got the correct, which is the correct setting. So again, this one, when I've plugged it in, it still says 1. So we know it's bigger than 200 ohms. Move it up, we know it's bigger than 2000 ohms. Move it up, it's bigger than 20 kilo ohms. Move it up again, and it's bigger than 200 kilo ohms. Move it up again, it's still saying 1. Now, two things could happen there. It could be that it is really big, or it could be I've not connected it properly. So if you keep getting the 1s, double check your connection, because look, I can now get that saying 699. Now that's not 699 ohms, that's 699 kilo ohms. So that would be 699,000 ohms. Okay, now you are going to use this multimeter to be able to do two experiments where you're going to investigate, first of all, a light dependent resistor, and second of all, a thermistor. And as I said, you don't need to know about how to use a multimeter in the exam, but you do need to know about how the resistance of these two components changes. So we're using our multimeters just so we can see that.